In this video, I'll be going over the other trig function graphs, so tangent, cotangent, secant, and cosecant. So first up is the tangent graph. So this is the basic tangent graph, y equals tangent of x. So a couple things are new in a tangent graph, also in a cotangent graph, that were not present in a sine and cosine graph. So first of all, we have some asymptotes here. So we have an asymptote here, here. In this image, we have 4 asymptotes, and what's happening is the graph increases, so here the graph is increasing, and it trends toward these asymptote lines. Similarly, where the graph is going towards negative infinity, it also approaches another asymptote line. Second thing to notice is that the period here for tangent is the distance in between the asymptotes. So here's the period length, here's a period length, and so on. And how we find the period length for tangent is pi over the b value, and we'll see what the b value is when we start talking about the standard form of the equation. This is how a standard tangent graph will look. Backing up the period length for this graph, well, the period length again is the distance between the asymptote lines, and that distance in this graph is pi. So again, the distance here is pi, and so on. So in this graph, we have a period length of pi units. Moving forward, oh, one last thing. We need to discuss what the domain and what the range is for a tangent graph. So the domain, what we have is everywhere the asymptote lines are, this is where the function is undefined. So the domain is going to be everything except where the asymptotes are. So what we would say for the domain here is it's all real numbers. So all real numbers except where x is equal to pi over 2 plus k pi, where k is an integer. So what does that mean? Well, at pi over 2, that value is not in the domain. At 3 pi over 2, that value is not in the domain. The next value is going to be 5 pi over 2. That's the next asymptote. Okay, so what's happening is we start at pi over 2 here, and then we add copies of pi. So 3 pi over 2, that's adding 1 copy of pi. In other words, k here is equal to 1. At 5 pi over 2, k is equal to 2, and so on. And we can also have k values that are negative. So that's how we would express the domain. And the domain just very closely corresponds to what the asymptotes are. The range for a tangent graph is going to be all real numbers. It starts at negative infinity and it increases to positive infinity. Alright, so now let's look at a cotangent graph. So a cotangent graph kind of looks like a vertical reflection of the tangent graph. What we'll notice is that the period length is still pi here. So the period here is equal to pi. We still have asymptotes. So this and this, these dotted lines, are asymptotes. And a key thing to notice about a cotangent graph is that it decreases. So whereas a tangent graph is increasing, a tangent graph is increasing, but a cotangent graph is decreasing. Let's see, what else do we need to say? Let's talk about the domain. And the domain here, it's going to be similar to what we had with a tangent graph. We'll say that the domain is all real numbers except where x is equal to k pi, with k being any integer. Okay, so again, what we're stating here is just how we find the asymptotes. So this value at 0, let's get a different color here. At 0, we have an asymptote, and at 0, we're going to say k is equal to 0. Here, at pi over 2, we have an asymptote. Sorry, this is a little confusing because the tangent graph is on here. So we're just looking at the red graph. So the red graph corresponds to the cotangent graph. So here we have a second asymptote for the cotangent graph. That would be k is equal to 1 there. So 1 times pi gets us pi. At 2 pi, well, now k is going to equal 2. And then in the negative direction, similarly, negative pi would be a k value of negative 1. Negative 2 pi would be a k value of negative 2, and so on. And then the range for a cotangent graph is just going to be all real numbers, so from negative infinity to positive infinity. And similar to how a sine and cosine graph worked, we could relate these values to the unit circle. Let's do the same thing here with cotangent. Let's take cotangent at some values on the unit circle and see how this relates to the graph. So some of the values of cotangent in the first quadrant are listed here, and let's evaluate these. Cotangent at 0, that's undefined. Cotangent at pi over 4 is 1. Cotangent at pi over 2 is 0. Cotangent at 3 pi over 4 is negative 1. Cotangent at pi, we're back to being undefined. Cotangent at 5 pi over 4 is positive 1. Cotangent at 3 pi over 2 is 0. Cotangent at 7 pi over 4 is negative 1. And then cotangent at 2 pi is undefined again. So let's see how these values correspond to what we see on the graph. So cotangent at 0, well, 0 is right here along the x-axis. This is undefined. That's where that asymptote line is. Moving to the right, cotangent at 1, we have a value of 1 right here. Cotangent at 0, so when x is equal to 0, I'm sorry, cotangent at pi over 2, well, pi over 2 is right here, right where we're crossing the x-axis. Cotangent at 3 pi over 4, we're going to be at negative 1, so right here, and then cotangent at pi, well, that's where this second asymptote is. So we've gone halfway around the unit circle. The next period will start at 5 pi over 4, 5 pi over 4. When x is 5 pi over 4, we're going to have a value of 1. At 3 pi over 2, that's right here at 0. 7 pi over 4, we're down in the negative side of the graph. And then at 2 pi, that gets us our next asymptote. So wherever on the unit circle the value is undefined, that corresponds to an asymptote on the graph. Next, let's talk about the steps we need to take to actually come up with a graph of tangent or cotangent, and then we'll see a couple examples. So the standard form for a tangent graph is going to be y equals a times tan of bx minus c plus d. So things are very similar to what we saw with sine and cosine. The only difference here is that now we have a tangent function. Similarly for cotangent, we're going to say y equals a cotangent of bx minus c plus d. So we got to get the given equation into standard form. To find the period, well, the period length for both tangent and cotangent is pi over the b value. So this is different than sine and cosine. Sine and cosine we had pi over 2b. Now it's just pi over b. Horizontal shifts are still going to correspond to the c value, and then vertical shifts are going to correspond to the d value. Okay, so just like all the transformations we've seen so far, the C value corresponds to a horizontal shift, so left or right, and then the D value corresponds to vertical shift, up or down. Next, we need to determine where the graph crosses the horizontal axis and where the asymptotes are. So the tangent graph, the period, we say the period straddles 0, and the asymptotes are above and below 0 by half the period length. This might be a little abstract, but once we see an example, this will be a little more clear. For cotangent, the period begins at 0. The period begins at 0, and the asymptotes begin and end there's an asymptote at the beginning of the period and at the end of the period. So asymptotes at beginning and end of the period. And again, a little abstract, we'll see once we get to a couple examples. So we want to come up with an equation for the asymptotes. So for tangent and cotangent, we do this in the same way. Because the asymptotes are vertical, the equations are always going to be x equals. We're coming up with equations of vertical lines. So to find the asymptotes, there's a few different ways you can do it. The simplest way that I know how to explain this is pick any asymptote, and then what we're going to do is we're going to add k times the distance between asymptotes. Okay, so this doesn't totally look like a mathematical equation. There's lots of words in there, but I think this will help you see how the asymptotes work. So we pick any of the asymptotes from the graph, so whatever it is, at pi over 2, pi, 0, or whatever. So we say x equals that first asymptote plus k times, and then we need to find the distance between the asymptotes. And this distance will always be the same anywhere we look on the graph. And then same thing where k is any integer. All right, and then the last things we got to do, we found all the information we need, apply any shifts to the horizontal asymptotes or horizontal intercepts, graph the asymptotes, and then come up with the graph. So let's look at a couple examples here. Okay, first we have y equals tangent x minus pi over 4 plus 1. Now the first thing is to write this into standard form. So there's not a lot to do, but I'm just going to be explicit about it. So a value is 1, tangent. The b value is also 1 here. So that will be the graph or the equation in standard form. The period will be pi over b, and the b value is 1 right here. So this will just be pi over 1, which is pi. So there's the period length. Now once we know the period length, I like to, on a number line, plot this out. Now, because this is a tangent graph, the period straddles 0. So 0 is here. Half the period is to the left of 0, half is to the right. So because the period has a length of pi, that means this distance right here is pi. That means this value on the x-axis is negative pi over 2, and this value is pi over 2. So what this is saying is the asymptotes are going to be at these values. Okay. However, there is a horizontal shift, and the horizontal shift corresponds to the c value. So negative pi over 4, what that means is we're going to go right pi over 4 units. So what I like to do is take those values that I found on the number line. I had negative pi over 2, 0, and pi over 2. Now we need to move all of these to the right pi over 4 units. So this new value right here at negative pi over 2, well, if I add pi over 4 to that, I'm going to get negative pi over 4. 0, if I add pi over 4, is now pi over 4. And then positive pi over 2, if I add pi over 4, I get 3 pi over 4. So this value right here is an asymptote, negative pi over 4, and then 3 pi over 4 is also an asymptote. Okay, so I think we found all the information we need. We applied the shift. So let's go ahead and come up with a graph. So the values we found, negative pi over 4, we're going to plot that. That's the beginning of our period. Pi over 4 will be about right here. That's the middle of the period, and then 3 pi over 4. That's the end of the period. So the beginning of the period is where an asymptote is, and the end of the period will also correspond to an asymptote. Okay, so there are the asymptotes. The middle of the period is where the graph is going to cross the horizontal axis. Now our horizontal axis is getting moved up 1 unit, so plus 1. So at a value of 1, let's put it right here, that is like the horizontal axis. Okay, so the x-axis, we're not going to cross at the x-axis, we're going to cross at this new horizontal axis. So we're going to cross right here. Now typically the tangent graph is going to be increasing. The leading coefficient is positive, so we don't have any vertical reflection. So this graph is going to increase towards this asymptote, and then it'll be going close to this asymptote. And there is the graph. Now we could come up with a second period representation of this graph. And to do that, all we're going to do is we're going to take the period length. Now, because of the way the screen is right now, I'm going to go in the negative direction. If we had more room, we could add pi to 3 pi over 4 to get a next asymptote. But instead, I'm going to subtract pi over 4, or I'm going to subtract pi from negative pi over 4 and go in the left direction. Doing so, if I take negative pi over 4 and I subtract pi, we're going to end up somewhere down here, negative pi over 4. So here is another asymptote, like this. The graph has the same image, same shape. It's still going to be increasing. It's going to cross at the middle of this period. The value there is halfway between negative 5 pi over 4 and negative pi over 4, so that's negative 3 pi over 4. And then this graph will be increasing like this, and then decreasing like this. Okay, so the only thing that we need to do is come up with an equation of the asymptotes. So because these are vertical lines, they're always going to be x equals. So like we said previously, we are going to pick any of our asymptotes as a starting point. It does not matter. Oftentimes we pick the first positive asymptote. That is not a requirement, but that's how I'm always going to do it. So 3 pi over 4 plus k times the distance in between asymptotes. So the distance in between the asymptotes here is the exact same as the period length for tangent. So the distance in between these asymptotes is pi. It's right here. So we're going to say 3 pi over 4 plus k times pi. So that is an equation for all the asymptotes. So this equation will generate every single asymptote. So no matter what value of k you choose, that'll get us one of the asymptotes. Now let's check out a cotangent graph. Again, first step, write this into standard form. We're going to say y equals 1/3 cotangent. Now we have a b value of 4, so factor out the 4. X minus, this will be, if I factor out a 4, this is going to be 2 pi over 4, or pi over 2 here. And then there's no vertical shift, so we can just say plus d. Now, if you're having trouble figuring out what the b value is and what we end up with inside of here, we'll just multiply. If you multiply this back out, we get negative 2 pi. So we know that we factored that correctly. Let's find the period length. Again, tangent and cotangent, the period is the same, pi over b. And the b value is 4, so this is going to be pi over 4 here. For a cotangent graph, the graph begins at 0 and ends whatever the length of the period is, so pi over 4. So what we mean is this is where the asymptotes are going to be. So we'll have an asymptote at 0 at pi over 4. And then halfway in between here will be where the graph crosses the x-axis or the horizontal axis, and halfway is just going to be pi over 8. Then we need to consider any horizontal shifts. We're going to say that we're going right pi over 2 units. So what that means is on this number line that we came up with, these values, 0, pi over 8, and pi over 4, we're going to add pi over 2 units. So instead of 0, we'll have pi over 2. Instead of pi over 4, we're going to have pi over 4 plus pi over 2, get a common denominator. We end up at 3 pi over 4. And then pi over 8 plus pi over 2, get a common denominator of 8. So pi over 8 plus 4 pi over 8 will be 5 pi over 8. So now at pi over 2 will be the beginning value of the period, so that's where the asymptote is. Then 3 pi over 4 is the ending value of the period. It's where the other asymptote is going to be. Let's go ahead and come up with the graph. So we'll start at pi over 2. We'll end at 3 pi over 4. And then we're going to cross right in the middle at 5 pi over 8. Now there's no vertical shift. We had a d value of 0. I think I wrote a 0 here, or a d there. That's 0. So we have no vertical shift. So the x-axis is still going to be the horizontal axis. We're going to have asymptotes at the beginning and the end for cotangent. Again, this is different than tangent. Tangent has asymptotes, or the period straddles 0. Here, for cotangent, our beginning of the period is 0. So the asymptotes are going to be at pi over 2, 3 pi over 4. A cotangent graph decreases unless there's a vertical reflection. We don't have a vertical reflection because that leading coefficient is positive. Now, because the leading coefficient is 1/3, this tells us we have a vertical compression. So what that means is this graph is going to get compressed vertically. So when we graph this, we're going to cross right at the middle, and when we graph this, this is going to be a little bit more shallow than what we would normally see because we have that vertical compression. So there we go. There's our one period of this cotangent graph. A couple things to mention here. This graph, not even close to being to scale. This x-axis should probably be much further to the left here. So I'm going to redraw the x-axis. The x-axis will probably be, let's see, 3 pi over 4, pi over 2. It's going to be way over here, or the y-axis, I should say. So the y-axis is going to be pretty far to the left here. So we're going to have another period or two before we hit the y-axis there. And then lastly, let's come up with an equation of the asymptotes. So again, x equals, pick any asymptote. I'll just pick pi over 2 here, plus k times the distance in between asymptotes. And again, that distance in between asymptotes corresponds to the period length. So times pi over 4. And again, that's k for any integer. I could have written this like this, x equals pi over 2, or rather, I want to pick a different asymptote. Let's pick 3 pi over 4 plus k times pi over 4. So either of these are 100% correct. Pick any asymptote, then add k times the distance in between the asymptotes.